All right, thank you everybody for making it. Welcome to webinar number 10. For those of you that are new, thank you for joining us, and anybody that's already been with us before, welcome back. Today we're covering dosing pumps and chemical metering. Give me a second here, we're still letting people in. Chuck, if you want to take that over.
Yeah,
maybe
just I got it.
Okay, excellent, thank you. So these are kind of the webinars that we've done so far. We're kind of going down the list. We had originally set up to do 12 webinars. Now we might be expanding, and we have another 8 lined up. So that's exciting stuff. We're actually getting quite a few people that are interested in doing some of these. Like I mentioned, this is the new YouTube channel. This is more of a soft launch. Little by little, we're editing the videos, and we're going to be putting them on there for everybody to have a look if you've missed any of them. Of course, this one's going to be recorded, and it will be up there in the next 24 to 48 hours, and I'll be sending out that link now. For those of you that are new with us or that don't know who we are, AWC Water Solutions, we are a water treatment company. We design and manufacture or supply water treatment plants worldwide. We've been around now for 40 years. We have close to 600 plants in operation, and we are based in Vancouver, British Columbia, Canada, or Langley, just east of Vancouver. This is our shop. This is what we do. It's really fun. We get to be able to manufacture everything in-house and test everything before it ships. And with that, we're going to just, I guess, one more slide here. We divide everything into potable, wastewater, and skid-mounted plants. So, this is kind of the technology that we go after. And with that short little introduction, I'm going to bring it over to Chuck. Chuck's going to be covering dosing pumps and chemical metering, like I mentioned. So, Chuck, go ahead, take it away.
Sure, thanks, Alex. Appreciate it. Just give me a second while I get this webinar up and going here, guys. Let me know if you can. Can you guys see that now?
Yes, we can.
Okay, you bet. So good morning. Thank you for everybody for joining. There's nothing more exciting talking about metering pumps. It's a pretty bland subject. I got to admit, out of all the lunch and learns that I perform and all the conversations I have with operators and engineers and generally end users, it's kind of a tough slog to get through. So I'm going to blast through this really quick. I'm not going to go deep into theory. I'm not going to go deep into things that I feel are kind of just fillers. We're going to just talk about this at a macro level. I'm going to show you all the more common types of metering pumps that are out there. I'm going to comment on what my experience has been on some of the general features and the benefits of those features are in those applications. I'm going to talk about the drawbacks. And we're going to talk very candidly about why we wouldn't use one in some applications and why we would use another in others. More importantly, I'm going to focus a little bit on supporting components because metering pumps by themselves won't meter properly without the right components. And yes, I'm going to say that out loud. And right now, if some of you are already distributors of other metering pump manufacturers, we can argue that and offline, but yeah, we're going to get into that. And then I'm going to just identify some of the North American common manufacturers out there in the marketplace. Getting right into it, most metering pumps are positive displacement. And obviously, being positive displacement gives us the ability to know accurately how much chemical or product you're pumping in per stroke. And that's obviously important when we're dosing hypochlorite, adding ammonia, all sorts of chemicals that we do in the water and wastewater industry. One of the more common ones out there is a diaphragm pump, which is just a simple diaphragm actuated by some form of mechanical shaft, moving back and forth with a known displacement. And the most common one in the industry is the solenoid operated diaphragm pump. Basically, it energizes and de-energizes a solenoid based on either manual or automatic control. These guys are low cost. You'll find them in multiple applications from I've seen them in polymer, yeah, hypo, ammonia, peracetic acid, all sorts of configurations. They're easy to use. They basically have one big fat dial. So obviously you turn it one way and you get more, and turn it the other. Ranging, down from half a liter an hour to up to 75 liters an hour. So we cover quite a huge breadth of capacity, and pressure is really not an issue for them on the high side. We can also get them in multiple diaphragm heads, meaning that, if we have, a flow and pressure issue, we can provide multiple diaphragms to increase the capacities. Some of the common guys out there, obviously, guys like Prominent, LMI, Syrah, Pulsafeeder. I think this is a Pulsafeeder. Don't quote me on that, but Milton Roy being another one. Pretty simple. Nothing to it. Exciting, eh? In the diaphragm range, there's also something known as a stepper motor. So now we go away from the solenoid and we actually move a microprocessor controlled motor, where we can control the speed and the position of that diaphragm more accurately. The advantage of a stepper motor is we get a longer life. They get a longer life than a solenoid. We can also control the suction stroke speed and the discharge stroke speed. So instead of, just hammering away, we're getting a slow discharge like a needle or a syringe action, and a fast suction. We can also control some of the pulsation, and obviously the ranges are really the same as the solenoid, around half a gallon to 75 gallons an hour at about 25 bar. And you'll see, like the Grundfos DDA, the Proteus, the Milton Roy Proteus or LMI Proteus. There's a few manufacturers of stepper motors. Let's just another one. Going into the bigger flow rates, and typically you'll see these guys on, let's say, on-site generation for hypo, where we're looking at really higher flow rates, maybe higher injection pressures. You're going to see a mechanically actuated diaphragm pump. So we go away from a stepper motor. We don't have a solenoid, and what we really have is a gearbox and a gear reducer in here, and it actually mechanically actuates the diaphragm back and forth. The reason why we go to this is we can actually provide better gear ratio and tighter control. And these guys will, in terms of maintenance, last considerably longer than you would find out of a solenoid operated diaphragm. Maybe a stepper, maybe slightly longer than a stepper, obviously because we have less load on the motor. Flow rates are up to 10,000 gallons per hour and more. Obviously, you can see we can go up to, some pump companies can go up to 56,000 psi. They cost more, but it's because of the additional components required, being the gearbox. We can typically get a higher viscosity ratings, 300,000 SSU. And what's really more common in the water and wastewater treatment is the hydraulically actuated version of this. So why that's important is we actually use a plunger that imparts displacement to a hydraulic fluid, which actuates the diaphragm. And why that's important is now we have even pressure on the backside of the diaphragm through that fluid pressure, and those diaphragm lives are very long. Obviously, pressure and is a component of that, but I've seen hydraulically actuated diaphragm pumps in operation for 10, 15 years that they haven't done a diaphragm change. So some of the pros, and I just want to stop about the diaphragm pumps because there's always a big debate in the industry sort of between two major technologies, that being diaphragm pumps and that being peristaltic. So I want to just I'll always talk about the pros and cons of each at the end of after I go through them. A well-maintained diaphragm metering pump will cost you less to operate over time if it's well-maintained. They actually are more energy efficient because we don't need full power all the time. It's only on the discharge stroke. And higher pressures, they have no issues with higher pressures. There's less danger of leakage, and that's comparative to, let's say, a Bellows pump, which I'll talk about later, or Peristaltic Pump, which is coming up on the next slide. The biggest disadvantage is that we need this fluid to be clean. The real reason is because a solenoid pump, a stepper motor pump, a mechanically actuated diaphragm pump uses ball checks for the suction and discharge, and those can foul very easily. That's why it's rare to see them in polymer applications or even soda ash applications or aqueous, because it has a tendency to build up on the seats and balls. They can't prime themselves when there's a lot of pressure. So a lot of these pumps to prime will have some ancillary way of dumping the discharge line pressure before it can prime. So the next type, which is probably very well known to most of this group, is the peristaltic pump. They can come at some of the lowest costs per stroke, I guess, if you evaluate that one. Really simple to operate, really quite easy to maintain. Most of the manufacturers have kind of offered a way to kind of change tubing very simply. The view windows provide a quick check, so operators have a tendency to like them because they can have a quick look and see, hey, look, that pump's turning and I know it's flowing. You know, there's no weird noises coming in. Initially designed and fantastic for slurries. A lot of the mining guys, aggregate guys, use these for pumping slurries all day long. A lot of the maintenance is around the hose, and that hose life is directly related to the pressure that they're operating against. And full range is roughly 0 to 160 gallon per hour on the peristaltic version. There are what they call a hose pump, just like this Vertiflex that's over here, where they actually use lubricant inside that, and those flow rates can go considerably higher, but rarely are they used in a water wastewater application. Again, looking at the pros, they're simple to use. They work well with solids. There's no check balls, so we can handle a lot of slurries and solutions and suspension. Really good at priming, really good. That squeezing of the tube, though, it weakens that tube eventually, and your feed rate will change. So most operators and people who've commissioned these units know that over time you're going to always be turning the adjustment knob up. So the motor's under constant load. So the motor's always under constant load. And I will tell you, if these pumps aren't changed out in a proactive or preventative maintenance ways, they leak. And when they leak, it's not fun. It's not fun to change. So you got to be up on the maintenance. And that tube, the minute that roller starts turning or the shoe starts turning against it, it starts wearing it. So you always have to keep an eye on and want to keep an eye on the number of hours that pump's been actually in operation. Another really common type out there is the progressive cavity metering pump. Some people don't even know that you can use a progressive cavity pump as a metering pump, but absolutely, without fail, you can. There's some major advantages. Obviously, low pulsation. We can handle thick and abrasive fluids. For polymer, especially, not especially, but just for polymer period, we have low shear on the fluid, which is very important. We don't have any valves to foul or wreck. Normally for the turndowns that people want on metering pumps, they're VFD driven. Most manufacturers have integral VFDs. They don't, with the full-on suite of analog inputs and controls. Range is up to 130 gallons an hour at 700 psi. So they're not afraid of much of anything. Their biggest disadvantage, I'll tell you, though, is that they can't run dry. And when I say can't run dry, I mean not for seconds. The other one that's out there is what we call a micro gear metering pump, or some people call it a gear pump. There's kind of different terms out there. These guys are really accurate at high pressures, especially if you need to move something at a high pressure that's a high viscosity. It doesn't say here, but they're not really fantastic at, let's say, flow rates above 500 liters an hour. But you'll find them obviously in like low pressure liquid propane gas fuels, doing pharma nuclear, where we need really tight repeatable accuracy, less than 0.5%. Most of the applications here are also metal, so we're not using plastics anymore to manufacture these pumps, or I shouldn't say we, but the manufacturers aren't. So they're usually using things like Hastelloy, alloy 20, titanium. So these things are actually built quite tight tolerance, and they usually last forever. There are some debates, but in general, you don't want to run these guys dry at all. And they do provide a nice pulseless flow. Here's one a few people might even raise their eyebrow to, that gets forgotten quite often, but is used with quite a lot of success. And it's a simple Venturi with a needle valve. If you have a system that's got motive flow, or you have a main line that has up to 80 psi, you can accurately meter from an ambient tank, sorry, not ambient, a tank that's at atmospheric pressure with a needle valve and a Venturi right into it. There's no moving parts. Obviously, a Venturi is one machine component. There's no power required. And if you're looking for that 1 to 2% repeatable accuracy, we can couple it with a V-notch. So a V-notch is basically a known area, and we can, so when we know the cross section and area of a V-notch, we can tell you almost exactly how much is crossing that. And if you want it down to that 1 to 2% accuracy, when you combine a V-notch with a Venturi, you can get just as accurate as a solenoid operated diaphragm pump or most peristaltic pumps. Where these are great for is dilution panels. So, if you're trying to take, 12% hypo and you want to dilute it to 6 or 3%, they're really good for that. Or side stream injection like sulfuric acid for pH control. A lot of people forget that these things exist. Now, this next one is the plunger pump, not to be confused with the mechanically actuated diaphragm pump, because there's no diaphragm here. Basically, it's a piston that's moving in and out of a sleeve. This is the Mac Daddy of positive displacement pumps for accuracy. It doesn't get any more accurate than this when we look pump to pump. So you're looking at about plus or minus 5% repeatable accuracy within 10 to 100% of operating range. And I don't think there's anybody else who can really say that. And that's most brands. What's nice about them is that they are modular in design, so you can add multiple heads. So obviously you can increase your capacity if need be. You're going to find these optionally, but mostly API 675 compliant. And use in excess of 7,000 psi. So high pressure side boiler feed, low pressure side boiler feed. Yeah, lots of options. What we like about these two is if you're doing molten liquid injections where you actually have to put a steam jacket around it, that has no effect on the displacement and has no effect on the accuracy. This is pretty much the last one on terms of pumps that are out there. The Bellows metering pump, this guy's been around for a long time. It's not too common in the water and wastewater industry, but it certainly has its applications, especially in high purity applications where you're using it in semiconductor manufacturing, film and X-ray equipment manufacturing, where you can't have any ion exchange from even what it's doing. These guys can also be electric or pneumatically operated, and they can also multi-stage the head, so we can increase capacity if you need larger flows. I will point out that kind of anything 50% and below of its stated flow rates, the accuracy drops off pretty quick. And the other advantage that we really like with these guys is that we can, instead of using a electric motor or a gear motor to drive them, we can actually use pneumatics or nitrogen. So they can be air operated or nitrogen operated. So again, that's why you see them in, X-ray equipment. So that was sort of the macro level of all the of all the metering pumps that you will run into. I mean, there's still probably 10 or more that are extremely rare that you only ever hear of. But I want to just put out a caveat to what I've just said, that all the pros and cons that I talked about and features are all generalizations of those specific metering pumps. Each manufacturer out there has special models or features of those models that can offset the problems that they've historically had. So what do I mean by that? An example would be, I said, peristaltic pumps have a hard time with tube replacement. Usually say, okay, well, Watson Marlow will have a quick change head to take care of that. I may have said, degassing or gas entrainment's an issue. Most pump companies now have, and have had for a very long time, auto degassing heads to handle off-gassing chemicals. I may have said, motor-driven pumps are don't have some control suites. You'll see that Prominent will have a built-in VFD with a controller on it. So don't take a lot of what I've said as like gospel. These are generalizations, and I just want to make sure that people understand that, I certainly will get calls from the blue and white guys, and I'll get calls from the Watson Marlow guys and even the Prominent guys about, I've said something here, but I didn't take into account their special model that takes care of that. So I just wanted to just provide some framework. I'm going to throw it out there, and I'm going to say it. None of these pumps will meter accurately if you do not have the required components for the system to operate as intended. So that's specifically a back pressure. And now the hose, the peristaltic pump guys will tell you we don't need a back pressure valve, and they're right. For the pump to operate, you don't need one, but you also need a back pressure valve to stop it. Siphoning effect that's happening. You obviously you're going to need a foot valve or strainer if if you're doing a suction lift application. You're going to want a calibration column. Possibly need pulsation dampeners. That's the system question. And I will put out there that when it comes to the injection point, that everybody consider and understand how retractable injection coils work. To me, this is a necessary requirement, and it's not optional. And then obviously a pressure gauge with isolator. On the right-hand side, you'll see a typical duty standby setup pump system with all those required components that are needed for these pumps to operate as intended with that accuracy and not give you any issues in terms of operation. Some of the common manufacturers out there, Prominent, Jesco, or it's actually Lutz, Jesco now, Lua, Grundfos with their Aldose, Pulsafeeder, I mean, you guys have probably heard some of these: MX Docero, Editron, Milton Roy, LMI, Axflow, Watson Marlowe, Milwaukee, Nikisio, which I haven't seen any in North America, but I have worked on some projects: Seco, OBL, and Blue White. These guys are probably the major players, with some minors out there that I'm probably not aware of. That's it. We're done. That was a real high level, guys.
Thank you, Chuck. We'll open it up to any questions. I really like how you have that little slide in there of who sleeps at work. I know you'll see that the technology in construction is pretty high up there. I'm actually surprised in construction is who sleeps at works, but that's scary. So what I'm going to do is I'm going to bring this over to me, make sure I'm sharing my screen. So we'll open it up to any questions. If anybody has questions, you can put it in the chat box, or you can turn on your camera and just anything you have in there. Let me just see. I have a question that came in through the chat real quick. Actually, I have a question for you. While anybody takes the time to punch something in there. You mentioned that there was a micro gear meter feeders that can handle very high pressure. When you say high, how high?
4,000 psi.
Okay, so they can go that high. Okay.
Yeah.
And you said the accuracy on them, like you mentioned that the accuracy is about up to 0.5%.
Repeatable. Yeah.
Repeatable. Okay.
Yeah. Yeah. So, yeah. So typically on a metering pump, they talk about repeatable accuracy, which is more of a function of, if I took a minute to fill this liter, did it take a minute to fill that liter again, or did it take more or less time?
Okay. All right. Anybody else? Any other questions? No, we're hitting our 26-minute mark, so we try to keep these as short as possible. Oh, I have another one here. Dawson's asking, I'm wondering about options for using Ethernet for communication to the metering pumps.
Oh, absolutely. Yeah. So full Profibus, Modbus, whatever bus you want. Most pump manufacturers have an option for that. RS-232 obviously is still an option. I guess it's really dependent on the manufacturer, but especially on the stepper motor and the solenoid operated diaphragm pumps and the peristaltic pumps, you should have options for full suites.
Okay, good point. All right. Well, thank you everybody for making it. If anybody has any more questions, you can stick around and punch them there. Just wanted to make a reminder, if anybody isn't following us on our LinkedIn page, we have a pretty active group. We put up there some of the communications we have. Go ahead and follow us there. For next week, we're going to be covering thermal desalination. That's going to be next Thursday, 10 o'clock Pacific, 1 p.m. East Standard Time. Thanks again for everybody for making it. I just wanted to give one quick note on desalination. A couple weeks ago that we went over desalination, I took some slack. A couple people were saying that we weren't covering the environmental impacts of desalination, and I completely understand and agree. I do want just to confirm that this platform we're using to take a look at technology and other technologies that are out there in the industry. We are not, unfortunately, we don't have enough time to really cover the environmental impacts for desalination or anything else, but I know that there's a lot of information out there. So I guess that was my full disclosure on my end. Thanks again, everybody, for joining us. I will see you next week. Stay safe. And if you have any questions, go ahead and send Chuck or I some questions, and we'll be in touch. Thanks again. Bye. Bye, Bill.